97 million downloads. That is how many times the core infrastructure tool known as the Model Context Protocol, or MCP, is being downloaded every single month.
It's a massive number.
I mean, it really is. And it's being pitched as the ultimate skeleton key for enterprise AI, the universal connector that lets any model talk to any internal corporate system.
Yeah.
But behind closed doors, a staggering 86% of these enterprise AI projects are just failing to launch.
Yeah, they just completely stall out.
Right. They die in security reviews, and they leave companies with, absolutely nothing to show for their massive compute budgets.
It is really the defining paradox in tech right now. I mean, we have this open source standard that completely revolutionized how we integrate models, but the delta between downloading a software development kit and actually surviving an enterprise security audit, it's proving to be an impassable chasm for most organizations.
Which is exactly why we are tearing into a massive new report today from the Agentics Co. It's titled The Enterprise MCP Guide 2026. Because if you are trying to understand where the corporate AI revolution is actually happening, whether you're an executive signing off on these budgets, a developer trying to stitch these systems together, or, just a learner tracking where the industry is moving, you have to look at the plumbing.
You really do.
Okay, let's unpack this.
No.
Because as we sit here today on July 6, 2026, there is a very real, very loud regulatory clock ticking down that makes solving this plumbing issue completely mandatory by next month.
Yeah, and to understand why everything is bottlenecking right now, we should probably establish what MCP is actively doing under the hood, because it has evolved aggressively since Anthropic first open-sourced it back in November 2024.
Right. So my understanding is that it essentially standardizes the translation layer, right? It's basically the USB-C port for AI applications.
That's actually a great way to put it, yeah.
Like before MCP, if you wanted an AI model to query a Postgres database and then, update a Salesforce record, you had to write custom bespoke API wrappers for every single interaction just so the model could understand the data structures.
Exactly. And MCP replaces all of that by standardizing the back and forth into JSON RPC messages. It forces the tools to present their capabilities in a uniform, machine-readable format that any model can just immediately parse.
Got it. So it removes the friction.
What's fascinating here is that standardization was the real breakthrough. I mean, getting a large language model to simply speak the same language as legacy internal systems, that was the primary bottleneck of 2024. And that's why it didn't stay an Anthropic side project for very long.
Right? Blew up.
Yeah. By December 2025, it was donated to the Linux Foundation's Agentic AI Foundation. So now it's true cross-vendor infrastructure. You have OpenAI, Google DeepMind, Microsoft, AWS, Snowflake. Every major platform vendor shipped MCP support within 13 months.
Okay, so if it has all this universal backing and, 97 million monthly SDK downloads, why is the success rate sitting at an abysmal 14%? I mean, if the code works, what is actually breaking?
Well, the deployment model is breaking. The Agentics report reveals that if you look at the top 20 most searched MCP servers, roughly 80% are offered as remote vendor-hosted servers rather than local installs.
Oh, wow. So they aren't even hosting them internally.
Right. Enterprises are actively choosing deployment models that they assume will be easier to manage centrally. But the catch is they don't actually have a central registry. What they end up with is this sprawling landscape of shadow servers.
I see. So a developer downloads an SDK to build a quick proof of concept over the weekend, connects it to a remote server, and then just leaves it running.
Exactly. And IT has absolutely no visibility into it. There is no registry that can tell a chief information officer how many of those downloaded servers are actively wired into a production agent versus just sitting exposed on the corporate network.
But wait, isn't that just a standard IT governance problem? I mean, shadow IT has existed since the invention of the cloud. Downloading an SDK is like buying a gym membership, right? Getting it into governed production is actually showing up to sweat. But if these tech giants are backing it, why is it so hard to map these tools to legacy internal systems? Why are security teams treating an unmonitored MCP server as fundamentally more dangerous than, say, an unmonitored REST API endpoint?
Because the attack surface is completely unprecedented. With a traditional API, you're generally looking at a direct, isolated connection between a specific application and a specific database. But MCP servers are designed to be aggregators.
They pool everything together.
Yes. They consolidate credentials from multiple enterprise systems behind a single interface, so the AI agent doesn't have to constantly re-authenticate across a dozen platforms.
Wow. So if an attacker compromises that one central MCP server,
They get everything.
they don't just breach the AI applications, happen. They inherit access to every single system that server touches and every other user relying on it.
It becomes a catastrophic single point of failure. And, you know, the analysts are tracking this very closely. The report cites Gartner's recent projections, and they are terrifying. By 2028, 25% of all enterprise Gen AI applications will experience 5 or more minor security incidents every single year.
Every year.
That's insane.
And it gets worse. A separate analysis projects 15% will suffer at least one major security incident annually by 2029, explicitly driven by these MCP attack surfaces.
That completely reframes the entire AI conversation. We've been so hyper-focused on whether the model hallucinates or says something weird, we completely ignored the risk of the actual integration layer. Here's where it gets really interesting, because it feels like we aren't just deploying software anymore. This isn't just hiring an intern. This is giving an intern the master keys to the HR database, the financial records, and the server room, all because they work really fast.
That is exactly how the Cloud Security Alliance is framing it. They've designated AI agents as privileged identities.
Privileged identities. Okay.
Yeah.
Yeah, these aren't just standard service accounts running automated, cron jobs. They are autonomous entities executing actions on behalf of humans, and they're often operating with permission scopes that far exceed the actual humans they're supposedly assisting.
And the security community is already categorizing the fallout from this, right? The report references an MCP top 10 threat list formalized by Alwas.
Yeah.
The terminology alone is just wild. Can we break down some of the mechanics here? Like, what actually happens during schema poisoning?
Schema poisoning is fascinating. It exploits how the AI understands the tool it's supposed to use. So when an MCP server exposes a tool to a model, it provides a JSON schema, which is basically the instruction manual that tells the AI, here are the parameters I accept, and here's what I do. Schema poisoning is when a malicious actor rewrites that instruction manual.
Wait, so the hacker alters the metadata the AI reads before it even takes an action?
Yes, exactly. The AI might look up how to query the customer database, but the poison schema has been altered to instruct the model to, say, append a malicious payload to the query, or to automatically exfiltrate a copy of the results to an external IP address.
So the model thinks it's just doing its job.
Right. The model thinks it's following the rules, but the rules themselves have been weaponized.
That is terrifying. Because the model itself isn't acting maliciously, and the database isn't fundamentally broken. The connection itself is lying to the system.
And that's just one vector. The Coalition for Secure AI mapped out about 40 distinct threats that literally did not exist in traditional software architecture. You have things like tool poisoning, where malicious commands are hidden inside the tool's actual execution environment.
Right.
Or you have context oversharing, where an MCP server handling multiple users accidentally leaks sensitive session data across different agent interactions.
Okay, so if IT and security teams are slamming the brakes on these pilots, it's not because they are anti-innovation or just being bureaucratic. They're scaring at 40 new ways to suffer a catastrophic data breach, and they have zero infrastructure to defend against it.
Zero.
But if internal security fears weren't enough to halt these deployments, the external legal liability is about to force their hand. Which brings us to the ticking clock.
The regulatory landscape is shifting from theoretical guidelines to enforceable law, and it is happening rapidly.
Yeah, as a reminder, today is July 6, 2026. And the Agentics report highlights that on August 2, 2026, so less than a month from right now, the European Union AI Act's high-risk obligations become officially enforceable.
This is where the technical architecture collides directly with legal liability. And the really fascinating detail about the EU AI Act is that it doesn't mention the Model Context Protocol by name at all.
Wait, it doesn't?
It doesn't need to. The Act explicitly covers the entire tool calling layer. If you read recitals 99 and 100, they directly target chained, multi-agent architectures.
I have to pause on that because the implications are massive. Wait, so the law is literally regulating the cables connecting the AI, not just the AI brain itself. How on earth does a company produce audit-ready evidence for a machine talking to another machine at light speed?
Well, the regulators understand that a foundation model in a vacuum isn't inherently dangerous, right? It becomes a high-risk system the moment it is connected to a tool that impacts human lives, like a system that screens, resumes, or processes loan applications or triggers financial trades.
Sure, but if an agent autonomously chains together like 5 different tools across 3 different MCP servers in half a second, how do you actually prove compliance?
You have to log the exact cryptographic pathway of the data. If an agent takes an action classified as high risk, the compliance boundary extends to every single component in that execution chain.
Oh, man.
Yeah. You can't just tell the auditor, well, the large language model made the decision. You have to prove exactly which agent invoked which tool, using what specific data payload, under what human's authorization, at what exact millisecond.
And if 80% of your deployments are unmonitored shadow servers, that level of granular auditability is physically impossible.
If we connect this to the bigger picture, this is exactly why Forrester projects that 60% of Fortune 100 companies are appointing a dedicated head of AI governance this year. Governance must be treated as infrastructure, not just paperwork bolted on at the end. The organizations surviving this transition aren't treating the August deadline as a massive compliance exercise. If the logging isn't built into the routing code itself, you cannot operate legally.
Okay, so let's summarize the battlefield here. We have 97 million downloads, but a 14% success rate. We have autonomous agents acting as privileged identities, 40 new threat vectors that bypass traditional API security, and the EU regulators literally knocking on the door in 3 weeks.
Yeah.
Given all of that doom and gloom, is anyone actually making this work? Like, are there real companies generating tangible returns using MCP in production today?
Yes, absolutely. But the defining characteristic of every successful case study in this report is that they built the governance infrastructure first, before they scaled.
Right. And the numbers coming out of these case studies are pretty staggering. Let's look at Bloomberg, for instance. They used MCP to close what they call the productionization gap, which is the latency between a developer building a cool AI demo and actually deploying it securely across their 9,500 engineers.
Right.
They achieve this by treating prompts and toolchains as code configuration. They build identity-aware servers that sit between the model and the data, which cut their experimentation cycles from weeks down to literally minutes.
JP Morgan Chase is another perfect example of treating governance as the product. They went into their massive $18 billion tech budget with a governance-first approach. They baked the compliance routing directly into their centralized gateway layer from day one.
Wow, day one.
And because they did that plumbing work up front, the report states they are now running over 450 distinct AI agent use cases in daily production. Their agents are autonomously generating investment banking presentations in roughly 30 seconds. Yes, that is deep analytical work that used to take junior analysts hours of manual labor. And on top of the time savings, they recorded a 20% gross sales lift from AI-assisted advisor outreach.
That's incredible. And we see the same pattern in consumer-facing deployments too. Klarna deployed an AI customer service agent that successfully handled the workload of 853 full-time employees. By Q3 of 2025, that single heavily governed deployment had delivered roughly $60 million in operational savings.
Forbes is another great one. They used a production MCP infrastructure to completely decouple their marketing workflows from their developer dependencies. They saved 18,000 developer hours annually while simultaneously doubling their landing page conversion rates.
Okay, but I have to push back on the broader claims here for a second. The report mentions that enterprises running these production deployments are seeing average ROI numbers around 171%. But it also notes these are vendor-reported statistics. We're seeing average ROI numbers around 171%, but are we just drinking the marketing Kool-Aid here?
I think that skepticism is totally valid, and it is absolutely survivorship bias. The report actually validates that if you read the fine print, you have to remember the core constraint we established at the beginning. Those massive ROI numbers only apply to the 11 to 14% of companies that actually made it to production.
Right, the ones that survived the governance graveyard.
Exactly. For the rest of them, the ROI is zero. They are paying exorbitant costs for cloud compute and API tokens and extracting no business value whatsoever.
Precisely. Which is why the final section of the Agentics report is so critical. It outlines the exact framework required to join that successful 14%. So what does this all mean for you, the listener? If your company is currently playing around with AI pilots, what is the very first thing you need to do tomorrow to avoid hitting a brick wall?
They call it the Agentics framework, and it relies on a strict, non-negotiable sequence: validate, govern, then scale. Not the reverse. The founder of the Agentics Co. noted that every single enterprise they worked with that attempted to reverse that order had a massive problem.
Let me guess. Companies that tried to scale 50 tools to 1,000 users before figuring out the governance.
Exactly. They had to completely tear down their infrastructure and rebuild it under extreme pressure.
It's like laying the plumbing, right? You have to check for leaks before you turn on the main water line to the house. If you just crank the water pressure on day one, you don't get a working sink, you get a flooded basement.
That is an incredibly apt way to look at it. The centralized gateway is your pressure valve, and the report outlines 4 specific technical capabilities that gateway must possess to achieve what they call defense in depth. First, enforced tool allow lists per agent.
Okay, meaning the principle of least privilege. An agent designed to, say, summarize meeting notes shouldn't inherently have access to the tool that executes database deletions, even if both tools exist on the same server.
Exactly. Second, and this is arguably the most difficult to implement, is OAuth 2.1 identity binding.
I want to dig into that because managing authentication for autonomous agents seems like a nightmare. How does identity binding actually solve the problem of the agent having too much access?
Well, traditionally, developers would just give the agent a standing global service account token so it could access the database uninterrupted. Identity binding fundamentally changes that architecture. It forces the agent to inherit the specific permissions of the human user it is acting on behalf of, not standing credentials.
Oh, I get it. So if I request an AI to pull the Q3 financial report, but my personal corporate credentials do not grant me clearance to view that specific database table, the agent's request will be rejected by the MCP server because it's using my scope token, not some God mode service account.
Oh, correct. The token passes through the gateway to authorize the tool execution without ever caching those credentials in the model itself. Third, you must have that centralized MCP gateway deployed as a reverse proxy.
Right.
Security teams need a single pane of glass to inspect the JSON RPC payloads, evaluate security policies, and log the cryptographic audit trail before the tool actually executes.
So no more shadow servers running on a developer's laptop. Everything routes through the central tower.
And finally, the gateway must enforce mandatory human-in-the-loop approvals for destructive actions. If the AI determines it needs to drop a database table or initiate a wire transfer, the execution literally pauses until a human cryptographically signs off on the request.
That framework validates, governs, scale. It just makes perfect logical sense. But looking ahead, the technology underpinning this is still shifting. The report outlines major infrastructure changes coming in 2027 to support this level of scale, specifically the transition from local Studio connections to streamable HTTP.
Why is that transition so critical for enterprise adoption?
Well, standard input-output, or Studio, is how MCP initially launched. It essentially requires the AI model and the tool server to run as processes on the same local machine.
Right.
It's brilliant for local development and weekend hackathons, but it is completely useless for distributed enterprise microservices.
Because you can't run a global banking infrastructure on a single local machine process. Right. Streamable HTTP leverages server-sent events, which allows these MCP connections to act like modern web traffic. Suddenly, you can place these servers behind proper cloud load balancers, distribute them across availability zones, and route them through enterprise API gateways.
So it scales.
It takes MCP from a localized script and elevates it into true, resilient enterprise architecture. Combine that with the formal interoperability standards that NIST, the National Institute of Standards and Technology, is expected to publish in Q4 of 2026, and the ecosystem is just rapidly maturing.
Which brings us to the absolute bleeding edge of this report. We've spent this entire deep dive talking about how an AI agent talks to a tool. But the future outlook points to something called A2A agent-to-agent protocols.
Oh, yeah. It is the next exponential leap in complexity. A2A governs how an autonomous agent negotiates and delegates tasks to another autonomous agent. The report notes this protocol is currently running in over 150 organizations right now, and analysts project it will become the absolute backbone of multi-vendor orchestration.
We started by acknowledging that the Model Context Protocol is the skeleton key for the AI revolution. It unlocks unprecedented integration and speed. But what the Agentics guide makes incredibly clear is that handing a universal skeleton key to an autonomous entity without a secure, audited gateway managing every move is a recipe for disaster, especially with EU regulators knocking on the door.
Definitely. And as we move into that reality, we talked about the A2A agent-to-agent protocol emerging. Think about the implications of that for a moment.
Okay.
If your perfectly governed, compliant AI agent autonomously delegates a task to a third-party vendor's AI agent, and that vendor's MCP server is compromised, whose governance framework is legally liable for the fallout, how do you even begin to audit a conversation between two autonomous machines that is happening entirely outside your corporate firewall?
Wow. That is a brilliant and deeply unsettling thread to pull on. The cables are finally connected, but we are only just beginning to figure out who is responsible for the electricity. Thank you for joining us on this deep dive. Keep questioning the architecture of the systems you rely on, keep a close eye on that August 2nd regulatory deadline, and as always, keep asking the hard questions about the tools shaping our future.